This chapter is about probability. So these first two lessons are going to be talking about probability, and then it'll talk about the difference between experimental and theoretical probability. So probability is you have to have an experiment in which an activity in which results are observed. The outcomes are all these different possible events in your experiment. An event is a collection of one or more outcomes. Favorable outcomes. That's what we're going to be kind of focusing on today. It's the outcomes of a specific event, what we're looking for. Probability is a number that measures the likelihood that an event will occur from 0 to 1. It can be measured as a percentage or as a decimal or as a fraction. Normally we look at it as fractions. We can describe the likelihood of an event occurring by using these words here. So you'll have impossible, which means it cannot occur. It will not occur. The probability of it occurring is 0%. You'll have as likely as not, which means it has a 50% chance of happening. So it's as likely to happen as it is not to happen. And then certain is 100% chance. If something is certain, it is definitely going to happen. So when you look at unlikely, it's going to fall anywhere between 0 and 50, but not be 0 or 50. And you look at likely, it's going to fall anywhere. It's a percentage that falls anywhere between 50 and 100, but not 50 or 100. So when we describe the likelihood of an event occurring, if we say that there's an 80% chance of thunderstorms tomorrow, the likelihood of the event occurring is that it is likely, because the probability is 80%. Describe likelihood of rolling a 7 on a regular number cube. Well, there's no 7s, so it's impossible. Flipping a heads on a quarter. Well, since there's a 50% chance, since there is a head and a tail, you have a 50% chance. It's as likely as not. Dr. Austin always wears jeans on a Friday. Describe the likelihood that he'll wear jeans on the next Friday. Well, it's certain. If you always do something, then it's certain that it's going to happen. And then if you have a 1/10 chance that there'll be no math homework, it's unlikely that you're going to have no math homework. So that is describing the likelihood of an event occurring. The next piece that we can look at is finding actual probabilities. So these are actually what we call kind of theoretical probabilities. We're saying that if we want to know the probability of a striped, we find the number of favorable outcomes to the number of possible outcomes. We write it as this ratio. So probability of the stripe, there are 6 different striped marbles in the bag. And there are 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 total marbles in the bag. So the probability of pulling a striped is 6 out of 10, which we then reduce to 3 out of 5. Probability of pulling a black marble, well, there's 2 black marbles out of 10. So that its probability is 1/5, 1 to 5. Not white. Well, since 2 out of 10 are white, then not white is 8 out of 10, which is 4 out of 5, which reduces. White or striped, so there's 2 white, and then there are 6 stripes, so that is another 8 total out of 10, which reduces then to 4 out of 5. So now here we can look at probabilities with a spinner. So what would the probability of spinning a blue? Well, there's 3 blue ones out of 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. 12 total. Always reduce, so you'll have 1 out of 4. Probability of not red, well, if there's 1, 2, 3, 4, 5 red, and there's 12 total, that means not red is 7 out of 12. Green or yellow, there's 3 green, 1 yellow, so that's a total of 4 out of 12, which reduces to 1 out of 3. And then probability of orange, well, there's no orange, so it's 0 out of 12. So that's finding your probabilities. It's the number of favorable outcomes to the total number of possible outcomes. Probability of randomly picking a strawberry starburst out of a bag of 45 starbursts is 2/5. How many strawberry starbursts are in the bag? Well, the probability is 2 out of 5. That means that X out of 45 are going to be strawberry. So here we can set up a proportion to solving. There's many different ways to do this. Proportion is one way. So we're going to get X equals, don't have my answer key with me, 18. So there's 18 strawberry. You would expect there to be 18 strawberry based on the probability of 2/5. Red pen out of pile of pens is 3/20. There are 12 red pens with the total number of pens, so 3 is your favorable outcome out of 20 total possible outcomes. So 3 out of 20 are red. Then if there are 12 red pens, there's X total pens. So you're going to have 3X equals 24, 240. So X equals 80. You would expect there to be 80 pens in the pile. Bag of marbles, the probability of picking a green marble is 20%. How many green marbles are in the bag? Well, 20% of them are green, and there's 65 marbles in the actual bag. We know that 65 times 20% is going to equal 13. You would expect there to be 13 green marbles. So probability, you can measure it with the ratio of your number of favorable outcomes, the total number of possible outcomes. We can also describe the probability by using those words of impossible, unlikely, as likely as not, likely, and certain. The next section that we're going to look at is going to be the difference between experimental probability and theoretical probability. When you have experimental probability, it says this is the probability of an event based on repeated trials. So you're actually spinning the spinner, or you're rolling a die, or you're flipping a coin. Theoretical is the ratio number of favorable outcomes to number of possible outcomes. So theoretical probability is like, in theory, this is what should happen. So if you flip a coin 30 times, your results are recorded in a table. The experimental probability of heads would be that 12 times that you flip the heads out of the 30 total trials. The theoretical probability, well, there's one head out of 2 total outcomes. So in theory, you should flip it 1/2 of the time, but in this experiment, you flipped it 12 out of 30, which reduces then to 2/5. So then tails would be 18 out of 30, which then you can reduce that one to 3/5. Okay, so that's your experimental probability, because in the experiment you did it 18 times out of 30 total trials. Theoretically, you should have flipped tails half the time. In this next example, a coin is flipped 200 times. The results are recorded. So heads, it landed on heads 98. So for experimental probability, it landed on heads 98 times. Out of the total, that's an 8. Out of the total 200 times you flipped it. So you reduce that, and you're going to get 49 out of 100. Again, the theoretical probability of it landing on heads should be 1/2, because there's one head out of 2 total outcomes. So the experimental probability of tails was then 102 out of 200, which will reduce to 51 out of 100. And again, the theoretical probability would be 1/2. So compare both coin experiments. What observations do you make? When you look at the first example, so it's heads versus tails, and you look, and your probabilities, you have 2 to 5 versus 1/2, 3 to 5 versus 1/2. The more times you flip the coin, the closer to the theoretical probability you actually did get. So in this next example, there's 300 M&Ms in a bag. When you pull out a handful of M&Ms, you get 5 blue, 7 green, 4 brown, 2 red, 6 yellow, and 1 orange. How many blue M&Ms would you expect to be in the bag? What we have here is an experimental probability. So we have this handful of M&Ms that we're pulling out right here. We have 5 blue, 7 green, 4 brown, 2 red, 6 yellow, and 1 orange. That's a total of 25 M&Ms. Based on this experiment, we had 5 that were blue. So in theory, there should be 5 out of 25 blue M&Ms. So if we're saying that there's 300 M&Ms in the bag, we should expect there to be X amount that are blue. So here you can set up your proportion, and what you're going to get when you do solve this is that X equals 60. You would expect there to be 60 blue M&Ms. So same concept for the next one. Here's 10 red marbles, 9 blue, 5 yellow in a bag. 16 are added. If the theoretical probability of both bags is the same, how many blue marbles are added to the bag? So in this example, we have that 9 out of 24 are blue. So 9 out of 24 are blue. You add 16, but the probabilities are identical. So that means that the total amount that are in the bag now are 40 total marbles. X amount are blue. So we can solve this and we'll find that X is equal to 15. That's 15 blue marbles that are in the bag now. There were already 9 in there. So in actuality, if you do 15 that are in there now, subtract the 9 that were already in there, 6 blue were added. So you can use these probabilities to make predictions and figure out when you do change the probability. In this next example, there's 10 decks of cards numbered 1 through 10. Cards are shuffled and placed face down. One card is selected and the results are recorded. Cards put back in the deck and shuffled again. The experiment is repeated 50 times. The results are shown in the table below. So here, the way this table works is that you drew a number 1 3 times. You drew a number 2 2 times. You drew a number 3 5 times. So on and so forth. So if you're looking at the experimental probability of an 8, well, you drew an 8 4 different times out of the 50 times that you did the experiment. That's an 8. It's not a 4. So 4, the experimental probability is 4 out of 50. Theoretical probability, then, you have 10 total cards. That's not changing. Just like in your experimental probability, 50 is not changing because that's how many times you did the experiment. Theoretical probability, the 10's not changing because that's how many total cards you have. What does change, though, is the numerator. So in experimental, it's based on this experiment, so it's all these frequencies. Theoretical, it's going to be, well, how many number 8s are there? Well, there's only 1. How many even numbers are there? Oh, well, there's going to be 5, which gives you 1/2. How many numbers less than 5? Oh, there's 4 of them, which gives you 2/5. So that's your theoretical. Your experimental is going to be based on that experiment. So the 2s, the even numbers, you have a 2, 4, 6, 8, 10, for a total in that one of 24, which is 12 out of 25. And then a number less than 5, so it's all of these down here, 7, 5, 2, and 3, which is a total of 17. This next question is now asking which card is the experimental and theoretical probabilities the same. So here you're going to want to look through and see which one is going to have the same theoretical probability as it does experimental. So we know that each of the theoretical probabilities are 1/10 for each of the cards. So you need to figure out which one up here has a 1/10 experimental probability as well. So when you look through that, you'll notice that card number 3, because it's 5 out of 50, which reduces to 1/10, and then also that's the experimental probability, and then the theoretical probability is 1/10. Bag of Reese's Pieces contains 21 yellow, 38 orange, 16 brown. The first 8 candies selected out of the bag were all orange. What is the experimental probability that the next candy will be orange? Take a minute and try to figure this one out. Pause the video and then restart it. So experimental probability is the key to this. So based on this experiment, if you look, the first 8 candies selected out of the bag were all orange. Therefore, the experimental probability of orange, 8 were selected out of 8. So based on that experiment, the probability that the next candy will be orange is 1. So with theoretical probability, in theory, this is what is supposed to happen based on the favorable outcomes to the total number of possible outcomes. Experimental probability talks about you have to do the experiment first, and then you look at the outcomes of that experiment.